Welcome to the December edition of tinyML Trailblazers. Yes, we are in the Christmas season already. And tinyML Trailblazers is tinyML Success Stories. This is the place where you meet people who drive this technology, who drive this ecosystem, who drive tinyML products forward, and people who are really mavericks in a way, masterminds of tinyML. They have tons of experience on the technology side and business side, and we are very happy and fortunate to bring this experience movers and shakers type of people to the global tinyML community. Today, our special guest is Christopher Rogers. Chris is CEO and founder of SensiML Corporation. So this is probably one of the early tinyML companies, and that's what we're going to have a discussion today. And I think in a way today is a unique event because we have two people, the host and the guest, with the same initials, CR, Chris Rogers and Chris Rowen. So I don't think it happened before. It's kind of first time in the Trailblazers. So you can make your wish. You're going to be between two Chris R today, and it's going to be quite educational, inspiring, and illuminating type of discussion as usual. So before we start, it is my pleasure to acknowledge our strategic partner and sponsors: AZIP, Analog Devices, Aeon Devices, ARM, DeepLight, HMPulse, PhotoHub, Greenwave Technologies, Gravity Inc., IBM, Imagimob, ITMIS, Clickertech, Microsoft, Nota.ai, NXP, OctoML, Prophecy, Hixo, Qualcomm, Rickson, SAP, SensiML, that's the company that Chris Rogers leads, Silicon Labs, Sony Semiconductor, ST Microelectronics, Stream Analyze, Synaptic, Syntiant, and TDK InvenSense. Just a reminder, tinyML communities are growing steadily and fast. You can join them either on LinkedIn or in meetups. On meetups, we have over 12,000 people in 37 countries, also growing fast. And LinkedIn community is also very strong, over 10,000 people, a lot of kind of information and materials there. Also, as usual, this discussion, this interview is going to be on YouTube this week. You can subscribe YouTube. We have a great collection of videos there, technical conferences, tutorials, over 500 videos, and more than 8,000 subscribers. So you can subscribe now for notifications and new videos there. And again, this video is going to be available this week as well. A little bit of preview what is going to be happening in New Year. It's supposed to be 2023 on January 11th. In a month, we have Luca Verre, who is also CEO and founder of Prophecy. That's a very successful French company, I should say also global company. Many companies are global these days. They work on event-driven neuromorphic computing. Also very interesting discussion there, and you can register now. We've been very fortunate to have Chris Rowen as the host for this interesting Trailblazer series. Chris is, I must say, a perfect person for this type of event because he has a lot of experience in the startup area, creating and leading companies. Some of them, like Tensilica, are widely known and very successful, and some smaller companies, like recently he was the CEO of Bubble Labs that was acquired about a year ago by Cisco. Another success story on Chris's long list of accomplishments. So again, he has a lot of experience in the startup area as an entrepreneur, and he's very passionate about technology as a technologist in his heart. He is one of the pioneers in the tinyML space. He's done quite a bit of work, and he's quite famous for his microarchitecture work, kind of indoors and risk type of architectures from the very beginning. He created MIPS computer systems, so a lot of experiences. And again, very, very fortunate to have Chris as the host. So Chris, the stage is yours at this point.
Well, thank you very much, Evgeny. It's so much fun to host this series where we really drill down on these three themes of what are the trends in technology? Where's the technology going? Where are the markets for tinyML going? And how does entrepreneurship work in that climate? And so we could have no better guest than Chris Rogers to talk about this, because I think that as founder and CEO of SensiML, and with a long history of working at this intersection between the hardware and the embedded applications in wearables, in a wide range of tinyML, we really couldn't have anyone who has lived the life and fought the fight that's always associated with trying to bring new technologies to market. He was the general manager for Intel's Quark and Curie machine learning software tools business. He was deeply involved in the evolution of Intel's big Wi-Fi and Bluetooth business. And he has really worked across end system applications and fundamental platform technology. And so this gives us a chance to talk about SensiML and put it into the context of tinyML, of entrepreneurship, of market trends in IoT. So welcome, Chris.
Yeah, thank you, Chris.
Maybe
always feels a little funny to say that, right? It's the Chris R show.
Yeah, right. Maybe a place to start is the origin story for SensiML.
Sure.
How did it come to be? How did you come to be involved? What was the core idea at its founding?
Mm-hmm. Yeah, so this would go back to 2012. At the time, I was working in a division at the time of Intel called New Devices Group. And this was a group whose mission, kind of first and foremost, was to advance the idea of computing platforms into the wearable space. So there was a group within that overall business unit that was focused on new business initiatives. And I inherited a project that was looking at basically like showcase applications for wearable computing. Intel at the time was, actively promoting, sort of new, exciting, cutting edge technology around how to take wearable computing to the next level beyond just simple, step counting gadgets, right? And so they'd had all kinds of, demos around things like, could we do form analysis and, motion analytics and other things that took, sort of sensing devices and did interesting things. And so as part of that, there was sort of machine learning as a core technology that was always kind of thought as part of that, a mix of that ingredient. And so I inherited a team that was working on a particular set of applications. And it wasn't long into that kind of got the notion that what was really exciting about this, and probably the best fit for a company like Intel, who wasn't so much a product company in the end system devices, but more of an ingredient technology company, that we should set about taking that idea of machine learning in the wearable realm and try to focus our team's efforts on companion tools that make that really possible. So that's exactly what we did. We kind of pivoted from, even in those early days, from the idea of let's come up with some, specific idea around a wearable device to let's focus on making a toolkit that can allow this wearable device to sort of progress from being the gadget it was, and it become really a platform, because some of the more challenging aspects of developing for sensor-oriented devices was made easier by tools, so that you could have an ecosystem of applications out there. So that's kind of where the start of this was very much like the same charter that we had with SensiML, but as a captive solution to help Intel advance what was at the time its Curie and Quark silicon.
And so who came together to do it? I take it it's a spin out at a certain point in time. And how did that team decide that they wanted to make the leap?
Yeah, so we had a good 5-year run within Intel, advancing these tools and promoting use cases for taking machine learning and showing how you could take the Quark SoC and Intel Curie device and build interesting applications with it. Right up until about 2017, at that time, then Intel decided to divest of that wearable business and the new devices group as a whole, and that was an interesting year of some real soul searching. I had been kind of a serial intrapreneur within a large organization, and it felt that the time came for me to decide if I was going to do that yet again, or if this was the time to kind of take the plunge and take what had been developed and was undoubtedly going to be shelved as part of that divestment by Intel, and see if we can't make something of it as a spin out. So obviously, as time has shown, we ultimately got excited. I say we, it was myself and sort of a core group of, we had 30 people at the time that were working on that project. And we took sort of the core, very passionate people that their circumstances were such, and their beliefs were such that they were willing to take the same plunge. And fortunately, that was a really good team in terms of the makeup of that team, and embodied sort of all the sort of key elements that we needed. And this was unique because you needed a machine learning and data science expertise. You needed somebody who really understood embedded systems and how to take generalized algorithms and reduce those in practice down to optimized code that can run on these very resource limited devices, as well as software development experts that knew how to come up with a good user interface to take a very complex task that in reality, most of our customer base were embedded people. They weren't data scientists, and make it easy or easier to practice machine learning without the in-depth expertise in that space. So we started SensiML in 2017, and kind of went out into the big scary world of VCs and funding and living by your early customers. And so yeah.
That idea of the inventory of skills that you had raises an interesting question of what is the inventory of skills and know-how and domain knowledge that your customers need to have? Because obviously, to bring to market a solution that includes Edge ML requires a lot of different things, some of which SensiML can reasonably supply, some of which you probably can't supply. So what are the things in your mind that make up the total inventory of capabilities that someone needs? And what are the things that SensiML provides? And what are the things that customers have to either have internally or are able to get in a complementary way to using your technology?
Yeah, so my sort of mental framework for this is a Venn diagram of 3 overlapping circles, where you've got, one circle is machine learning expertise and data science. And more broadly, that kind of includes also DSP, numerical methods and algorithms, right? Somebody that can take a solid understanding and a good intuition of what it takes to take the physical sensor data that they get, construct the necessary data sets supervised machine learning data sets in most cases, where you're labeling for some events that you're trying to seek to understand or recognize, and implement those within the AI frameworks that are available. So that's one. The other is embedded development. People who know the nuts and bolts of microcontrollers and how to program those devices efficiently, taking advantage of every opportunity to make those devices power efficient, because oftentimes those can be battery powered devices, but certainly they run on very limited CPU and memory footprints. So that's yet again another realm of expertise that's needed. And then the third is the domain expertise within the particular application that's required, right? And embedded being what it is, that's all over the map, right? You have consumer, you have industrial applications, you've got agricultural, you've got remote sensing, and it's a long tail of applications. And so the big challenge is that of those three circles, the two that we can address are the first two. It's really incumbent on the user to be able to provide the value add for their particular application, because there's no way we could build a team to possibly have expertise in all the available areas. So that's what we focus on, is providing automation and seeing how far we can move the bar from requiring teams to have all three of those skill sets solidly, to be able to rely on automation and tools for at least the machine learning aspect, and to some degree the embedded design too, where they can take a library and then incorporate that within the rest of their application or firmware that they're ultimately trying to build for their tiny device.
Yeah. Now, one of the typical challenges in that is that you're bringing the data science to some extent, but because the data is very application specific, they're bringing the data. So how does it work? Do you find typically where, you've got one party that has the science and the other party that has the data? How do you bring those two together in a way such that customers bring the right data, can curate that data appropriately, who have an understanding of what kind of data is going to be required to do that? Because there's this is where the rubber meets the road,
right?
Often in terms of having a successful application, getting the right data into the whole mix.
Yeah, and to be blunt, that process can be somewhat messy, just because of customer expectations and I think common perceptions of what machine learning can do.
Yeah, I mean, it sometimes seems like magic. And how to describe to a customer how magic works in technical detail is hard.
Right. So all too frequently, customers come and say, "Oh, we have data. We have lots of data." Right. That's great. We don't need to collect data. Let's import what you have and work with the existing data sets you have. And invariably we find that that data wasn't collected with a machine learning approach in mind, and we're missing key aspects of that, such as context information about where that data was derived from. What were the conditions under which those sensors were recorded, much less the labels for the regions of interest that you're looking for. So ideally, a customer has some data set that can be readily imported and labeled, and then we can go through the process of doing the AutoML and generating a model. And it's kind of a mix. And I think that the challenge there is because of users' expectations of what machine learning can do. It's easy to condemn the technology based on kind of a flawed understanding of what the limitations are for these types of things.
In practice, what's the mix of fundamental sensor types? Let me oversimplistically say there's motion data, there's audio data, and there's video and image data.
Right.
What's the distribution in your own experience for SensiML?
Well, there's some bias in there, right, for us, because we have purposely chosen to focus on only a limited set of data. So most people are most familiar with AI and machine learning as it applies to image data and object recognition and you know, that type of thing. That's actually the one area we don't do, right? We focus on everything else. We thought back in the time frame where we were looking at, certainly it aligned to what the wearable computing space was looking at, was, you know, how do I take motion data or even audio? But it also, as we were contemplating spinning out, it seemed to us to be a very underserved area of the market. You know, all of the billions of sensors that are found in factory environments and industrial settings, and most of the AI research was focused on image and spatial data.
I think that's in many ways a smart move, because you can easily argue that if any area of Edge ML is over invested in, it would be vision. It's, you know, it's kind of obvious. It has a superficial sexiness to it. It demos nicely, but it doesn't mean that that's where the insights live. And it's a lot of computational effort to do it. So it's a little bit, can be at odds with really trying to fit into, you know, mass deployment at ultra low cost.
Right. And we were very much focused on not only the sensors, but kind of the alignment of that plus the appropriate hardware that fits with that, right? The kinds of processors that were running at microwatts, not GPUs that needed watts of power in order to do the processing. So,
yeah, along the journey, every startup, in fact, every organization, you know, hits something between a speed bump and a brick wall, and picks itself up and chooses a new direction or figures out how to get around that barrier. Give me a story of one of those speed bumps or brick walls, and what you learned from that process of doing it. This is such an essential unifying theme in entrepreneurship that you learn from experience.
Right. Yeah, it's one. So for us, it was really sort of the classic dilemma of horizontal versus vertical markets. You read about that in business school. You see the Harvard case studies, right? And you can even sort of consciously know these things, but to live them, it's still a struggle. And to explain more what I'm talking about, we had always envisioned this tool as kind of like Excel is to spreadsheets, right? Excel isn't marketed as a tool to, you know, build a P&L model per se, or to, you know, capture my recipe files. It's a multi-purpose tool that can be suited by its user to do, you know, whatever their particular application is. And we saw this as kind of the same kind of thing, which was a general purpose tool for anybody that has sensor data that's time series based to build models that can run on ultra low power devices, right? But the reality of the market in you know, the time frame when we started, and even today we're still very early in this market, is that you've got customers who don't fully understand you know, the process of doing data-driven design. They're used to coding, right? So it's a mindset shift from going from you know, curating code that embodies sort of my intuition about what these algorithms need to be able to derive the value I'm looking for, whether that be like detecting a movement or you know, a fault condition, to curating a collection of data that represents that, right? And so it's an investment into a sort of a different business process of how to develop data. And so as a result, what we had was early customers that said, I'm not so much interested in the tool, I just want the answer, right? You know, I'm looking for something that can detect these 5 gestures. Can you do the work for us? Not, you know, I'm willing to invest time into learning your tool and developing a skill set and capability within our team to be able to do that n number of times ourselves. For now, our first AI project is we just need this feature, and we'd be happy if you did it instead. So we found that oftentimes we were struggling between focusing our efforts on building features and capabilities into the toolkit that allows for a scalability of this market space to the sort of near-term realities of keeping revenue coming in and paychecks to our employees, and serving the customer needs as they existed at the time. So that was really kind of a struggle. And
how do you think what's the balance that you struck? How did you decide, okay, this customer is worth going a step towards a solution for them? And how did you decide, no, that's too far? We're either not going to choose to do that customer, or somehow we're going to convince that customer that we have provided enough of the ingredients and that they can pull together the ultimate solution for themselves. How would you articulate now the compromise that you reached?
Yeah, there was always kind of an assessment that needed to take place of, is this within our core competency, and does this help add value to the tool, versus are we getting pulled astray? The reality of embedded design is that the problems you face aren't just the ML piece. It's system level issues of, every one of the hardware drivers and sensors is different. There's no commonality in these things. Wireless stacks, we found ourselves spending time, trying to debug BLE issues, right, and creating custom GAT characteristics and other things that had absolutely nothing to do with machine learning, but we're still sort of key towards being able to solve the customer's need at the end of the day, that they wanted a model that they could convey into the cloud from translating raw sensor data into events of interest. Right? So, we just had to kind of continuously examine the scope of work that we were doing, and those things that made sense, those things that didn't. Along the way, we would discover that the customers had, flaws. We had an example of one was that their sensor was not repeatable, right? So the challenge we had was, in that particular case, this was kind of a high-profile customer for us. We had to kind of come to terms with the fact that the data that was coming in was garbage, and no amount of machine learning was going to solve that problem until first they tackled the issues with the source data and the sensor itself not being repeatable. So we made some challenging decisions there around trying to convey that in a way that was going to keep them engaged, but still point out that these were issues that were kind of beyond what we could solve.
Yeah, right. Yeah, I mean, those are real scars from real world engagement. So here's a question: what do you think you've learned in the last 5 years since the spin out that you could have applied back within Intel that would have made that wearables effort more successful? Maybe the environments are so different. Success as a new effort within Intel may have nothing to do with success in the real world, but there are always some ties. And I'm curious if there are lessons, things that you wish you knew then that you know now.
I think one challenge has been data sets, right? It's almost like a cliche now that, data is the new oil, right? And, those that have the data really have the key IP. And while there's certainly a lot of truth to that, the nature of the embedded space being so long tailed is that there was absolutely no way we could come up with enough data across different applications to be relevant to customer X, right? Even when we had what we thought was a bullseye of, okay, you're looking for a pet finder or a pet wearable device that could track your dog's activities. We'd actually done that, oddly enough, back in the Intel days as a proof point. But this customer was looking for different activities than the ones that we had chosen at the time. So, you did this idea that you have, data sets sitting on a shelf that can be readily translated into IP. In reality, it was very tough to do because there's so much sort of situational specificness of the data sets and the requirements of customers, what they choose to do with it, what sensors are they using, that type of thing, that's in practice very difficult to do.
Yeah,
in a kind of generic way.
I mean, that's really a statement that the statement of data is the new oil is really missing the point on one big idea. West Texas crude and North Sea oil and Saudi Arabian oil are all pretty much interchangeable. It didn't matter where you got it. It's oil. Whereas, this idea that you need data specific to a certain pet activity in order to have any data at all is wildly different. And it's not that data isn't valuable, but irrelevant data is totally valueless. And you have to find a way to pump your own oil from your own patch. And that's the only data that has value. And
Right.
That's a tricky thing because you have a community of people in the end applications who know they have data, but they don't know anything about the characteristics of data that make it good. And you who sort of have evolved over 10 years of working in the field, you know what good data looks like, even if you don't know the specific problem that you're solving with the data. And so you have to bring that ownership of data and knowledge of what makes data valuable together in one place.
Mm-hmm. Exactly.
Yeah, really, really interesting. So as you think about this space, I'm going to ask about market trends and technology trends, but what are the market trends first that you see that are important, the things that people are trying to do, the things that are affecting the ecosystem of how solutions come together, the kinds of end customers your customers are trying to serve. What's going on market-wise?
Well, yeah, we see sort of hotbeds of activity around different sectors, right? One is industrial sensing, and the use cases there are either like process monitoring, anomaly detection, or predictive maintenance. Those are very strong sort of early killer applications because they have a high ROI to them, right? If you can do anything to prevent a factory line from going down, that's got big dollars behind it. So you want to do what you can, and you can invest accordingly to make that happen. And then juxtapose that to consumer devices where ML is largely around feature differentiation. I've got a washing machine, but my washing machine has AI features and can recognize keywords, and you can turn it on without having to push a button. Right? There's some value to that, but obviously it's a different kind of value than the former, right? So I think we see lots of activity in health and wellness devices, typically in motion and gait analysis and form analysis within industrial applications for. And this is interesting because often you hear predictive maintenance, but in order to get predictive maintenance, you have to really be able to characterize the process very well. So what's often described as predictive maintenance is really anomaly detection. They can easily capture data for baseline, normal behavior of a machine. But if you're Otis elevator, for instance, you're not going to send the elevator car into free fall so that you can get an example of here's what it looks like when the cable snaps, right? And that's kind of a silly example, but there's actually a lot of truth to the fact that what in these industrial use cases, they're trying to find those disaster scenarios, but they don't have a lot of data in order to go through a modeling process to reliably train and not overfit to the few data points that they actually have.
And moreover, the definition of a disaster is it's something unexpected, and sort of saying, well, you have to anticipate all of the unexpected things in order to be able to get any value.
Or purposely cause it, right?
Yeah.
So that's sort of an interesting aside on that space, which is what we see often described as predictive maintenance, often is more anomaly detection and baseline, and looking at deviations from baseline.
Yeah, right. Now, one of the classic dilemmas I think that startups, well, every company runs into is how do you go deep in wellness without falling over the edge into medical devices and FDA approval and that whole different regulatory regimen? Where's the sweet spot that allows you to work with customers who get to market in finite time, yet provides deep value, deep insights of the sort that people care about in health and wellness?
Yeah, it's a tough issue. I'm actually pleasantly surprised to see sort of the current generation of wearables starting to get into the space of looking for things like atrial fibrillation and some of the other cardiac events that while it just seemed like this is an obvious thing, right? We could help people because the technology-wise, it's easy to take one of those electrode signals and analyze it and look for these kinds of patterns. Being able to productize that and get FDA approvals is another matter entirely. So I'm almost surprised to see some of those things starting to come to light. As far as we're not heavily into that FDA process. Of all the challenges that we have, fortunately, that's ones that our customers are more better suited to navigate through for the ones that are in that medical wearable space. What we can do is make sure that we have reproducible algorithms so that when they need to be able to put that clinical trial data together, that they've got solid data to draw from and repeatable models that they can use. So that's probably the extent to which we get involved in sort of that regulatory process.
Now, what about technology trends? What are some of the big things that you see coming in terms of algorithms or sensor types or computing platforms or constraints or opportunities that are created by the march of underlying technology?
The thing I find the most exciting is the progression in hardware, right? From our old company, Intel's Moore's law, right? Is it busy at work in SoCs that we see, and the advance of these ultra low power devices that have AI acceleration capability built into them just allows these devices to do more within the power envelope that they have, right? So as these come about, we're starting to see opportunities for what we consider to be the tinyML MCUs to be able to do more. When we first started, this was another dilemma that we had, was that we saw lots of these early startups who had great ideas for better SoCs that did more than just used MCUs and software to do algorithms, but could offload some of that into hardware accelerators. For us, it was a difficult challenge to decide to make a bet on a bet because they had installed bases of 0 themselves. So as a startup, these are almost bet the company kind of decisions about who your ecosystem of partners are. So while we could cheer on the sidelines for a lot of them, it was very difficult to make the plunge to partner early with some of these innovators. And so we had to make sort of the conscious choice to go after the traditional large players in the MCU space and believe that this technology was going to find its way into mainstream products coming from the tier 1, tier 2 players in the market. and we're starting to see that. We did something with Silicon Labs. They have a product they call the XG24 that has an AI accelerator. So I'm very excited to see how that's going to evolve and just make the capabilities of the hardware such that we can take advantage and do more interesting things.
Yeah, certainly for the first few years of AI acceleration, my observation would be that one of the recurring themes was that these accelerators had lots of theoretical performance. If you measured multiplies per watt or multiplies per dollar, they were off the charts. But in many cases, they were virtually unprogrammable. You know, either the architectures were very narrow and specialized, or the tools weren't mature enough to get the job done. Has it changed? How has it changed? And what do you now get to sort of assume as the kind of functionality that you would, expect at a minimum for an embedded platform with ML acceleration on it?
Yeah, we explored many of those where it was very early in the process, and they didn't have the SDKs and the compilers even fully sorted yet, and we weren't eager to get into an R&D experiment on some of those early things. So we very consciously drew the line at if you have libraries that we can call, or a compiler that we can integrate into our back-end model compilation workflow that could take a given model or a neural network and implement it and compile it into whatever is needed, for their accelerator, then we can work with you, right? But we did not want to get into the space of having to get into sort of the R&D work to put the fundamental building blocks in place, the compiler technology for their particular hardware. Yeah.
So has it gotten significantly better? If you look at accelerators today, do you generally find, hey, they kind of do what they're advertised to do?
Yeah, I think it's improving. You go back to our former question. There's a lot of interest in image, right? So I think some of those building blocks have again been focused mostly on how do I process image data, and so the time series focus that we have, it's the case where a number of those devices don't yet have similar types of accelerators for time series workloads, right? You have to kind of go back to is it vector multiplication and fmax that they can provide sort of those building blocks and we can just call those, or do they have mature libraries that are really focused on the kinds of workloads that we cater to?
Yeah. Let me ask one really nerdy question on this out of personal curiosity. One of the things that we've seen in practice is that neural networks can often be pretty numerically sensitive, and therefore aggressive quantization to get down to first 16-bit, then 8-bit, maybe 4-bit representations is a lot of work and has a lot of uncertainties. And therefore, we've sometimes found that there's tension between the idea of quick time to market and super low cost implementation using very low resolution arithmetic in these things. What have you found in your world of how much work it is to get from floating point implementations down to whatever is the tiniest fixed point implementation that a platform supports? Or do you tend to bypass that question and just say, well, as soon as I get to 16-bit floating point, I'm reasonably happy, and the hardware does a good enough job that I can go from there? What's the role of low resolution arithmetic in the tinyML applications you tend to actually get successfully into the market?
Yeah, that's a great question. So there's sort of that aspect of quantizing the neural network and the tricks you can do to approximate it on hardware that doesn't have an FPU. But the other thing that we run up against is most of our customers, when they talk ML, they equate machine learning with neural nets, and that's all they think of. And we spend some time just trying to educate users that the field of machine learning is broader than just neural networks, and I think people have become enamored with that to the exclusion of other things that are entirely appropriate. So our comment is always the best model is the one that gives you accurate results in the smallest footprint possible and consuming the least amount of power. Sometimes that's a neural network. Sometimes that's a Bayesian model. Sometimes that's a decision tree. Sometimes that's a distance-based classifier, right? All these other algorithms exist in machine learning and are completely viable, particularly when you're talking about time series data. So we try to encourage our customers to explore other alternatives rather than sort of fixate on, well, I need to have a neural network for this. And
that's a good point.
So
do you generally find that then the less deep models are more numerically stable, and therefore you don't wrestle as much with the numerical precision questions?
Yeah, we find that you can build some of those models more compactly, and for the very reason you just described, and so we actually support 8-bit microcontrollers, which nobody thinks of 8-bit for neural networks. They're just there's not enough memory footprint there, in 16-bit, much less 8-bit. But we support 8-bit microcontrollers in the case of the old Atmel devices, now part of Microchip. And so obviously we're not doing neural networks there, but there are plenty of use cases where you can do a great job using decision tree models or distance-based classifiers and provide the performance you're looking for.
Oh, very interesting. Anything else on the technology trends? When you look out 5 years, what do you expect the problems and the technical solutions will start to look like? Not
being a data scientist myself, I'm a practical application engineer. I'm a mechanical engineer by trade, so I'm always fascinated by this stuff, and I'm not the one to ask of what sort of the next algorithm is going to be for optimized sparse neural networks per se. We've built our toolkit in an extensible way as a plug-in architecture, so that as those people that are the experts in that, we can incorporate those models into our toolkit. Our focus has really been on taking the workflow and process and making it accessible to the typical customer or developer of ours who isn't like myself a data scientist and without the deep expertise in those types of things. So for instance, TensorFlow Lite and TensorFlow Lite for microcontrollers is an engine that we've incorporated as one of the modeling options within our toolkit, and we are looking at other engines that we can add to the repertoire, where you can take those frameworks and sort of incorporate it into a standardized workflow. So I look forward to see sort of what the cutting edge for new algorithms and new models will be, and how do we incorporate that in a way that's usable without having to get deep into Python and write stuff in programmatic ways that is generally outside of the realm of most of our customers.
Got it. We've got a few questions that have come up. Let's pivot towards those questions. Plus, I note for the attendees that there's a poll that's come up. So please also kind attendees look at the success stories poll as well and fill that out. Stefan asks, what consumer-oriented killer applications would you see in automotive enabled by tinyML, enabled by SensiML?
Yeah, automotive is, I'll be frank, that's probably an area we've seen the least in so far. We have had some customers that were doing predictive maintenance to make common maintenance items around the vehicle chassis, something that can be understood readily with easily implemented sensors, right? So if you look at most of the vehicle's drivetrain is controlled and heavily monitored by the ECM, right? And there's standardized interfaces there to be able to pull and diagnose those systems quite well. But the aspects of the vehicle that aren't well covered have to do with chassis, things like wheels, tires, brakes, suspension, wear components that can affect the drivability and safety of the vehicle. And so those are ignored areas that can be well aligned to vibration monitoring and taking IMU data and being able to look for those patterns early on. So that's actually, it kind of goes back to my early days. I was a test engineer at Michelin Tire coming out of my undergrad. So I was doing that kind of stuff, and I thought it was great fun to work in that space. But to see those kinds of applications kind of brings me full circle back in my early days.
Got it. Lewis asks, most motion data that has been collected for tinyML consists of data from consumer-grade devices, which were never meant for applications requiring much higher accuracy. Have you handled data from much higher accuracy capable sensors, inertial sensors, for example? Does that help streamline what you do, and if so, how?
Yeah, it's always sort of the cost issue, right? We have worked on some of that data. In fact, some of the stuff for structural health monitoring uses ultrasonic data that can be hundreds of megahertz. Or hundreds of kilohertz, I should say, from piezo sensors are different than the MEMS-based sensors you see sort of in high volume applications coming out of the smartphone space, right? And so if you're trying to detect extremely transient events like crack propagation on a pressure vessel or infrastructure, like I'm monitoring bridges or other things, those types of events, MEMS sensors are too noisy for, right? So we have worked with those. From our standpoint, it's all just time series data, so we're fairly agnostic to what the sensor type is. At the end of the day, it comes down to what is it that you're trying to detect, and in some cases where you need that high sample rate in order to catch some of those transients and work in that frequency space, then yes, you need to go into the more sort of exotic sensors.
Yeah. Here's a question from Nital. It's really about new generation memory devices. How do you see MRAM versus SRAM for embedded ML?
So we've had some early explorations, but I'll have to be honest, I haven't explored that too deeply yet. So I don't have a strong opinion there at present.
Yeah. There's a whole series of questions, question from Harriet, question from Nital, an anonymous question that basically amount to, how do I get started? What are the best resources? What advice do you have for someone developing their careers? What online courses would you take? How would you guide newbies who really want to move up the learning curve?
Yeah, I mean, at this day and age, so much of these resources are available online and for free that I wish I had access to those kinds of things back when I was starting.
Yeah, right. It seems almost unfair in retrospect.
Right. So a couple of things. One, from our own resources at SensiML, we make a version of our toolkit available for free. We call Community Edition. And if you go to sensiml.com/plans, there's a link there to the free version of the tool. And we have lots of example codes where you can get started without having to put together a complex demo. It's basically, you can take one of these low-cost eval boards and get started with the board itself, because a lot of them have multiple sensors integrated within a very small form factor board. You plug it in over a USB or use BLE, and you're off and running. From an ML standpoint, there's Coursera courses that you can go look at. In terms of any specifics, there's probably a variety of ones that could point to maybe offline. If you're interested, just drop me a note at info@sensiml.com and I'll follow up with some links. But there's just a wealth of material that's out there. So by all means, take a look at our website, and we have lots of examples, at least on how to use our AutoML. And our tool was really designed to be one that could grow with your capabilities, right? So at the outset, knowing nothing about machine learning, if you can get an embedded system to connect and start capturing device through what we call our data capture lab tool, then the actual machine learning, you can just have the system do it, where you basically set some constraints, and then you press the green button, and it goes and thinks about it and comes back with some candidate models. And then you can kind of learn from what the system picked, because as you explore those models, you can look at what it selected, what the features it chose for the pre-processing, what type of classifier and how it set the parameters for those classifiers, and kind of learn from what the tool decided to select. Mm-hmm. And then as you go, then you can be more prescriptive to say, I'm not going to use the AutoML so much. I'm going to go in and define some things and try out some other ideas of my own and sort of evolve.
Oh, that's pretty cool. Yeah. Last question, briefly. Well, where do you see the future of SensiML, near and long term?
So I think one of the things that's been a real aha for us in, say, the last year is that some of our better customers have turned out to be what we originally thought of as partners. So, and what I mean by that is that we're an independent software company, and I think part of the challenge for a big end user that wants to adopt tinyML is, SensiML, I've not heard of these guys. Are they going to be around in 5 years? And am I going to, bet my product on, whether they're going to continue to innovate and grow? But that question is not one that comes into their consideration when they're talking about their tier 1 semiconductor manufacturer, right? So for us, what we've found is that kind of taking a lesson from our old Intel progenitor is that you don't have to be the brand for everything. It's perfectly okay for us to be sort of a private branded solution that's incorporated in some of our partners' tools, and we're good with that. So what we've learned is that that's a much more effective way for us to scale our business, is to be the ML technology, the tinyML technology that gets integrated into partner tools. And so near term and midterm, I see us continuing to sort of not only promote our own solution, but to forge the same sort of core technology within some of our partners' tools as well.
That's great. Well, with that, thank you so much, Chris. It's been really a delight, and I really enjoyed chatting with you. And let me
likewise.
Turn it back to Evgeny.
Yeah, thank you, Chris and Chris. I think it's been a great conversation. So I think Chris Rowen asked you a lot of good questions, and the audience asked really good questions. So I have a very trivial question for you, Chris, at the end, if you follow our series a little bit. So we are in the success series, and obviously you are a very successful person, entrepreneur, leader. both during your Intel days and now kind of leading SensiML into the kind of bright future there. What is success for you, Chris, personally?
Success is when we have customers telling us that we've helped them accomplish what we set out to do, which was to take what has been a very challenging combination of embedded design and machine learning and made it easier, so that we start to see some real innovation take place in the embedded world, right? Where things that used to be really hard. The first step counters that came out, they were done by hand by teams that had great intuition. So for us to really see a proliferation of sensing and machine learning, it needs to be something that can scale. So when we start, as we start seeing more and more customers sharing positive experiences of being successful, that for me is the ultimate win.
That's a great win-win type of answer, definitely. And Chris, Rowen, I haven't asked this question to you. I mean, your resume is beyond being successful. I mean, you have like 100 pages of your accomplishments. What is success for you, Chris?
Always a good question. I ask myself that from time to time, but it's really kind of old-fashioned. I think that it has ultimately come down to two things. One, in some very idealistic way, I want to change the world. That is, introduce new technologies, help in the proliferation of valuable and benign ideas that leave some lasting impact. And second, to help people, just to help people develop their careers, help people understand how to avoid some of the brick walls or turn some of the brick walls into speed bumps as they look to innovate, as they pursue their goals of changing the world. So kind of being a mentor and advisor, if you will, to make some of these things happen.
No, that's great, Chris. I think the world needs more pragmatic idealists like yourself, who kind of both drive the technology and to change the world, but also enable an army of people who are passionate to make it happen. I think that's great.
Yeah, right.
Thank you. And just at the very end, let me acknowledge again our strategic partners. The list is here. And one by one, it's ARM, Edge Impulse, Qualcomm are the executive, and Syngent are the executive partners. The platinum sponsors are DeepLight, Clickertech, Reality AI, Renaissance, Sony. Gold partners, Analog Devices, PhotoHub, Microsoft, NXP. This one is Seed Studio, SensiML. I mean, we talked about SensiML quite a bit today. ST Microelectronics, Synaptics, and we have many silver sponsors. So thank you again for joining. We wish you happy holiday season, and we will see you in January, on January 11 with Prophecy with Luca Veri. Thank you all. Bye.